Good morning, everybody. I will be talking to you about the next hour or so about some of the things Pat has been talking to you about as well, getting stuff into production. And the thing I will be focusing on is how do you do that with your secrets, your passwords, your certificates, that kind of things, and how do you deliver them to your applications in a secure way. So before I start, I'm kind of wondering who here thinks he's doing DevOps? So that's like 4 people out of 25. So you other guys, how are you delivering your software? Do you have a centralized center of excellence that does shipment of code? Sorry? Okay, fair enough. So, but are you in control of the build and the release and shipping? So most of you are? So how do you manage your secrets right now? In a secure way, you think? And to rephrase that, can you easily change a password for any service you're using in production without interrupting operations? Who can? Sorry? Okay, so you have to redeploy. Okay, well, let's see if we can find ways to change that in this session. So, the importance of, I think, secret management for developers, as we are, is evident to everybody. We used to have this way, where we have a development team creating software, creating artifacts, binaries, handing them off to a separate team that is deploying stuff. And some of us might even still be there. But now we're doing this DevOps thing. And for me, in practice, it means developers taking on more responsibilities. This idea of getting ops people into the team, I haven't seen in my world, at least. So often, we are getting new responsibilities that we're not used to, like secret management, configuration, that kind of thing. So it's a new thing we're taking on, and that makes this an important topic, in my opinion. So, when you're talking about access and secret management, there are a number of things you want to achieve, in my opinion. The first one is no shared credentials. For example, if you have 4 APIs going to the same storage account, you want to try and create 3 keys, each for one of them. Another thing you want to do is create the principle of least privilege. So if 2 people need to access the same storage account, but they all need access to different parts of that storage account, try if you can see and give them access to only the portion they need. You do this for persons, you want to do the same thing for systems. So third, you want to get something specific going, and it's in my opinion, you don't want ever want somebody having access to your production environment. So no developer or operations guy for that matter should be able to open up the portal for your production environment. That's like the ultimate thing you should be trying to achieve. The only one with access should be your release management suite, like VSTS or Octopus Deploy or something like that. And finally, and that's also a thing we're going to achieve for our applications, you want to try and decouple authentication from authorization. Homebrew authentication is the thing we've learned to avoid, right? So let's try and do the same thing for our applications. And what I want to do with you is share with you, or take you on a journey, share with you 4 approaches on trying to manage your secrets in a way that gets more and more secure, but that you may or may not be able to do so depending on how far you are in your DevOps journey. So the first approach is probably applicable to all of you, and the second maybe as well, and at the third you might say, well, okay, we can do this for limitations in our company. So that's what I'm trying to do with sharing 4 approaches. But before I do that, you might be wondering, who is that guy? My name is Henry. Since the 1st of March of this year, I'm an independent guy. I'm a ZZP'er, as we call it in Dutch. I've been working in Alkmaar and Amsterdam, currently in Eindhoven, at medium-sized companies, so not really corporates. If you want to hit me up afterwards, feel free to, and I will be also around for an hour or 2, 3 at least after this session. So let's get going. Let's take a look at 4 approaches for getting secrets into production. And this is the first one. We're going to use our release orchestrator. And the example I'm going to use is VSTS, because that's the one I'm most familiar with. And this is a really basic approach where you store all your secrets, passwords, inside your release orchestrator. And most release orchestrators have this thing called password fields, where you can only put something in and cannot read it back. So that's kind of secure. Of course, they store it in a database below the surface, but if you're using a managed service, you can make that somebody else's problem. And if you're using a thing like VSTS, I'm going to trust in Microsoft handling that secret in a much more secure way than I could ever do myself. So what we're going to do is save our secrets, and then while we're doing a deploy from VSTS, we're going to inject those secrets into the binaries or the configuration just before it is deployed onto the actual machines that our code is running on. So when would you do this? In my opinion, you want to do this when you're doing continuous deployment of your code, but you're not in charge or able to change the infrastructure. For example, you cannot do infrastructure as code, or you cannot change the environment you're deploying to, maybe an on-premise IaaS server, or a app service that is delivered to you by a separate team that you cannot change in any other way. In that case, you're probably stuck with this approach. So let's take a quick look at what that looks like. I paid a lot of money for this image, so you're going to see it a couple of times. So the running example for this talk is going to be a really impressive ASP.NET application that has the sole purpose of showing a secret on screen. Might be a bit weird, but that way we can validate that it's going to change between development on my local machine and the actual value in production or after release. So I'm going to store a bank account password in my viewback and display it. And what I do, I'm getting that bank account password from my web config. So that shouldn't be weird to anybody of you, right? Cool. Now I can run this and we'll get something amazing going up right about now. There we go. We have this development value on screen. So let's see how we can get that into production. So what I'm using is VSTS, and I have a build definition going up, and I'm going to assume that this is familiar to most of you. So for who this is complete, utter new. A couple of people. Okay, let me quickly show you around. In VSTS we have two things, one called build and one called release. And in a build we're going to take our sources, fetch them from source control, compile them, and the binaries we're going to store in something called an artifact. Then we're going to do a release where we pick up this artifact and we're going to ship it to one or more servers or app services. So that's the abstract ID. And both a build and a release are made up of a number of steps. So here we're looking at a build, which selects a version of NuGet. Well, first it gets my sources, then it selects a version of NuGet, then it does a NuGet package restore, it compiles my solution, and then it takes the zip that's created and stores it as an artifact. That's my build. So for those familiar with builds, nothing fancy. And I hope the rest can tag along now. So after this build, I'm going to do a release. And in this specific case, that release consists of just one step, namely deploying those binaries, that zip file, to an app service, which is basically an IaaS server. What I can do, I can point to the web app and the app service name that I want to deploy to. I pick a zip file, and one of the things I can do here is I can override app settings. So what I do is I'm going to override the bank account password with a value bank account password, which is a variable in VSTS. These variables I can also define within my release, and like I said, this is a password field, so I can only put something in here and I cannot retrieve it again. After I have released this, I'm going to press F5. I will get this, where you can see there is a new value rendered into my web application. This is the most simple way of secure management of secrets. Any questions so far? Ready to step it up a notch? Yes? Yeah, awesome. That's bad. So, what are the pros and cons of this approach? Well, we can see that our secrets are pretty secure, especially when we're trusting in someone like Microsoft to manage them. It's easy to start with, and it will fit a lot of existing situations. There are some cons though. You have to see and copy secrets, so they have to go through your hands. And if you have a lot of people in the company, that might be a security risk. Also, you can still log into the portal, if you have the production access, and can just see the secrets there in plain text. So that's not cool either. You're also going to duplicate your secrets from wherever they are to VSTS, which might not be really handy every now and then. And you can definitely not change them easily that way. So you have to change them somewhere, change them in VSTS, and do a new release. So you're going to be down for a couple of minutes. Unless you use a neat trick. So let's take a quick look at that trick. And it's going to make one assumption, that's that you have a primary and a secondary secret. That's the thing you'll get out of the box with, for example, Azure Storage accounts. It's the thing you can do with shared access tokens. It's the thing you even can do when you're creating accounts or access keys. And the approach is quite simple. When you want to change the secret, you're going to change the secret in your release orchestrator to the secondary secret. Do a release, roll the primary secret, get the primary secret back in, do a release, roll the secondary secret. Both secrets are changed, you didn't have any downtime. Easy peasy. Now why do I start with putting in the secondary secret? I'm going to operate on the assumption that we're always using the primary secret. That way we don't have to guess which one is in there. Let's take a look at the second approach. And in that approach we're going to use infrastructure as code, ARM templates. So who is using ARM templates actually? Who has no idea what ARM templates are? Okay, let's take a couple of minutes to explore those. ARM templates are a complete declarative description of the infrastructure you want to have in your cloud environment, in this case Azure. And there is also an AWS equivalent of this. So you're going to say, I'm going to want a app service with this name that should be deployed on a web server farm with this name, which I'm defining here, which is running on 2 VMs with 2 cores with 1.5 gig of memory. So you're really writing down your complete infrastructure. And what you can do is you can also release this infrastructure into Azure, like you just saw me do with a app service. Now the funny thing is that such an ARM template can declare a number of parameters at the top. And we can change, vary these parameters per environment we're deploying to. So we have an ARM template.test.parameters, ARM template.production.parameters. And instead of just putting in values, we can also put in a reference to an Azure Key Vault. Now, you might be wondering what's an Azure Key Vault. An Azure Key Vault is a service in Azure that's just a key ring in the cloud. That's basically it. You store your secrets there. So, and you can reference them from an ARM template, and they will, within Azure, so after pushing your template to the cloud, they will be taken from that key vault and pushed to the place where you want them. So they're never ever leaving the cloud anymore. That's great. But you can go even further. What you can also do in an ARM template is you can, for example, provision a storage account, and a bit later in the template you can get the access keys from that storage account and echo them somewhere else. So you're not even duplicating the secret anymore to your key vault. You're just moving them from one service to another. And that's a more secure way, in my opinion. That's what I just told you. So when can you do this? When you as a team are allowed to, or are actually deploying infrastructure. So you have to get these keys from the storage account, for example, and echo them to the app service. And you also have to have permission to create services on your own, because not every team is allowed to, by some centralized architect, for example. So enough talk, let's take a look at what it looks like. There we are again, like I promised. So here I have another solution let's not lie. Here I have another solution which is basically completely the same. I have this web config with a secret that I'm going to echo onto the screen. But instead of just the application, now I also have a second project in my solution, which is a resource group deployment. And this contains both the description of the infrastructure as the parameter files. So let's take a quick look for those who are unfamiliar with ARM files. If you are familiar with ARM files and you haven't heard of this thing called the JSON outline, do look it up. Ctrl Q, search box on the top. It's the best thing ever. It will save you a lot of time editing this JSON file. So an ARM template consists of 5 parts. Parameters, the things you can change per environment. Variabelen, difficult word. That's expressions you can define once at the top and reuse throughout the template. Then you get your resources. That's the things you want to deploy to Azure. And then you can have outputs. And those are the things that are actually echoed back to the thing calling or instantiating the deployment. So parameters are declared like this. Name, type. You can make them an enumeration if you want. That's it. So there are a number of them here. And below those, variable, which I'm not using, and then my actual resources. So I'm deploying a storage account here. I'm deploying a key vault. I'm deploying a hosting plan, which used to be called a web farm. And I'm deploying an app service on top of that. And within the app service, I'm deploying app settings. And as you might expect, here again, I'm overriding the password to use. And I'm also using a storage key. Because what I want to show you is 2 ways to do this. First of all, I can echo in a parameter. And I can do this really difficult expression to list the keys from my storage account with this name, using this ARM provider. Take the primary key, its value. So it's a really difficult expression. Do not try to figure it out ever. Go to github.com/ARM templates getting started. Everything's there. Copy paste it. So these are the things that I have in source control. And from here on, I'm starting a new build where I'm not just compiling binaries, but I'm also taking these 2 JSON files and putting them in my artifact. And from there on, I can do a new release. With, in this case, 2 steps. The first one being an Azure deployment, taking this template and pushing it into Azure. I'm going to point at an Azure subscription, and I'm going to point at a resource group, a location, and I'm going to point to my template file and my parameter file. And I'm golden. After I've done this, I'm going to ship my binaries, just like I did before. No longer an override of the app settings, because the app settings were in the ARM template pushed to the app service environment, and they will take precedence over everything that's already in the web config. That's what I wanted to show here, except for some proof. This is the value that's been getting from the key vault. Any questions so far? Yes, Fanny.
Just quickly go back to the release screen.
Yeah, definitely.
So every time a release is done, this Azure deployment rate will update the resource group will run.
Yes.
Will it actually, if it already exists, the app service, will it drop it and recreate it, or will it just update it? How does it work?
So the question is, if you're deploying the same ARM template over and over again, what will happen? Will it destroy everything? Will it just update it? Or will it do nothing? Well, there are 3 modes you can deploy an ARM template. The first one is validation. That's just going to make sure if it can actually deploy your ARM template. So, useless. Then we have incremental, which says I'm going to look at your ARM template, and I'm going to look at your actual resource group, and everything that's in your template and not in your resource group, I'm going to add. And if it's already there, I'm going to leave it alone or update it if things have changed. So it's an idempotent operation. Now you can also do a complete deployment. This is like for people with guts. Because what it will do is it will also take a look at your resource group and identify things that aren't in your ARM template, and it will just drop them. Now why is that awesome? First of all, if you get rogue people still doing stuff in production, like an intervention, instead of working from source control, they will get, how do you call it in English? They will learn they should start working from source control to get changes into production instead of just clicking around in the portal. So everything they do, it will just get erased every time you do a deployment. And you try to do those 1,000 times a day, right? Another thing is, for example, if you have some kind of a persistent threat where somebody changed some settings unknowingly, unauthorized, you will just write them over. And the more often you deploy, the bigger the guarantee is that what you have running in production is the same as what you have running, what you have in your source control. So for example, if you want to scale up a virtual machine, probably start in source control and go through your whole pipeline. Does that answer the question?
But what about downtime then? Let's say it's running and you're supposed to have this.
Well, if you're using an app service you can choose, you can just let it replace the files, which will take like 5 to 10 seconds, depending on how much files you have. You can also have it take the web app offline, so it will put something like an offline.html in some weird directory, and then it will say this application is currently offline. Another thing you can do, but then we're really getting into the way app services work, you can deploy it to a slot within the app service, and you can even heat it up there, test it there, whatever, cuddle it, and then you can do another third step here where you can swap this slot and the production slot. But then we're really leaving the realm of secret management. Anyone else? So, watch me failing forward, right? I've done this wrong once and I'm doing it better now. So, what are the pros and cons of this approach? Well, we're no longer copying secrets around by hand anymore. So that's a win. And we're trying to avoid duplication of secrets as much as possible. However, there are two things still standing, and that's the secrets are still visible in the portal. Because when I log into that app service, I will see the app settings in plain text. And I'm still stuck with the same procedure for rolling secrets, which is bad. So, let's move forward and see if we can find an even better approach. Which I call using secrets directly from the key vault instead of moving them at deploy time. So what we want to try to achieve is give our application a runtime Azure Active Directory. And when that application has an identity, we can grant it access to the key vault. And that application can retrieve the secrets by itself from the key vault whenever it needs them. Maybe do some caching, because you're paying per access to the key vault. But that's the idea. So how do we give an identity to a web app? Well, what we can do, we can go to the portal, we can create what we call an app registration, so we're typing in a name and a URL and some other bunch of stuff. And now we're getting two things, a client ID and a client secret. So we're somehow left off with all our secrets in the key vault, great, and then getting back one secret to access our secrets. So where we're going to leave that secret. So we're having an issue here. And recently Microsoft introduced a new service, a new feature into the app service, which is called Managed Service Identity. And with Managed Service Identity, when you turn it on, which is just a toggle or a true-false in your ARM template, Microsoft will automatically provision a new service principal in your Active Directory and run your application under that principal. And also provide you with both a URL where you can retrieve bearer tokens and a secret that you can use to retrieve bearer tokens. And that way you can authenticate yourself as that identity and then access the key vault from the application. So that's the third approach. Make sense? When would you use this? same reasons as before, but now there's something else you need. Two things. You need to have permission to use non-GA stuff, which in a lot of companies I think is a big no-no. And also you need permission to start steering in the Active Directory. And again, at a lot of companies, especially larger companies, sysadmins won't like it when you start provisioning identities in groups and doing things as a developer. So there might be some organizational reasons you cannot use these. But what if you can? You might be wondering, how am I going to do local development? Because my application in Azure has an identity that can access the Key Vault, but the one I'm developing on my local machine, it doesn't have it, so it cannot access that Key Vault. There are basically three ways we can deal with that. The first one is grant your developer access to that Key Vault, or even better, a Key Vault with the development time secrets. The prerequisite is that the machine the identity of the developer has to reside in the same Active Directory as the Active Directory that is backing the Azure subscription. Or in practice, the developer has to be in an Active Directory that is synced to an Azure Active Directory that is backing the Azure subscription. So in large organizations that might be the case, but in a lot of smaller organizations, these two are probably completely disjoint. So if that's the case, you cannot use this. If you can, this is definitely the best way to move forward. What I'm doing in my demos is number 2. What I'm going to use, I'm going to use the Key Vault when I'm running in Azure. So I'm going to create basically a feature toggle to switch between two ways of retrieving my secrets, depending on where I am running, locally or in Azure. I'm going to show this to you. And you have to write some code yourself to do this. This code is really straightforward, but you have to do it. And you really have to make sure that the thing in Azure is not breaking down, because then your application is working great locally, but it will be broken in the cloud. That's why we have tests. And another thing you can do, which is actually I think the recommended way currently on MSDN, is, well, let's create an app registration with a client ID and a client secret and get those into my web config and use that to retrieve a token and access the Key Vault. But now I'm again stuck with a client secret in my web config. So I can either not check in web config, which will work out 10 times, and then somebody will screw up the 11th time, and then you have to roll the secret and everybody is angry, etc. So just don't do that, in my opinion. But it's a valid way forward, according to some. Make sense so far? And let's take a look at this beautiful picture. So there are a number of things I want to share here with you. And the first one is that I have to change the code in my controller a little bit, because I'm no longer running on the values in my web config. So, like I said, I'm going to split my code in two ways of working, one for local and one for in the cloud. And the way I'm going to do that is by seeing if I'm actually running as a managed service identity or not. So that check's quite simple. I'm going to check the existence of two environment variables. Now you might be frowning upon this, because that sounds a bit dirty. Okay, it looks really dirty. However, this is actually the recommended way currently. So when I'm running as a managed service identity, I can use a thing called the Azure Service Token Provider, which is brought in as an NuGet package. I can instantiate the Key Vault client using a token that I get from the token provider, and then I can retrieve secrets from the Key Vault. That's it. Really straightforward. Again, all this code is on MSDN, just don't try to figure it out yourself. And if this is not the case, I'm just going to fall back onto my web config value. That's it. Now you might be wondering, does this actually work? It does. It does. Surprisingly fast even. So let's recap this. What's great about this approach? We have No manual copying of sharing of secrets anymore. We have no more duplication of Azure keys or other things that are easily shared between people and systems. We no longer have secrets visible in the portal. So somebody having access to my Azure subscription can no longer retrieve secrets to access services behind my customer-facing service. And finally, when I change a secret in the Key Vault, I can program the code I just showed you to try the secret, and if it's not working, just retrieve it again. And that way I can automatically incorporate changes in my secrets in Key Vaults into my code within milliseconds, not interrupting service. So that's also a thing we gain. However, when I made this talk a couple of weeks ago, it wasn't generally available yet. So that might be a showstopper. And it's only available on Azure Web Apps. So if you're using other ways to host your code, you cannot use this approach. So let's take a look at the best way ever. At the start of this talk, I mentioned to you, you want to try and separate authentication from authorization. And we did this in the previous example. But we used our identity to go to another place where there were still secrets stored. What if I could use my own identity to just go to a service, like we're doing with things like OAuth, instead of using my identity to retrieve secrets that can be stolen and go to a service? Well, that's a thing that we can do in Azure as well. So let's take a look at that. Again, an identity, and we're going to give that identity permission to access a service directly. And this is like the prerequisites are the same thing as in scenario 3. Added that the service you're calling has to have support for this. And there is very, very limited support in Azure for this nowadays. However, if you're doing microservices, and apparently nowadays everybody is, you're creating a lot of services maybe, that you're calling from your own code, then you can get your own services to support this. So that within your own application landscape, you don't have a lot of secrets going on, but you can start relying on identities backed by Azure Active Directory. Let's dive in and see how this works. Again, code-wise, it's quite straightforward. I have changed the code on my home controller a bit. I'm still checking if I'm running as a managed service identity. If I'm not, I'm falling back onto app services, redundant else. And if I am, I'm again using the Azure token provider, but instead of just give me the token, I'm going to get a token for a specific scope. And I've chosen for Azure SQL DB. Why? Azure SQL DB is one of the few services that support authenticating as an Azure Active Directory user. And from .NET Framework 4.6.1 and forward, I can also use my SQL connection string builder, like I'm used to, and then set an access token on the connection, which is, as you can see, not using a user ID or a password, and then open a connection to the database. So now I'm accessing a database in a secure way without passwords, which to me is like, hooray, best thing ever, done with passwords. Now you might be wondering, does this actually work? So let me hit F5. It does. I'm doing connection.open, which will throw an exception if I'm not authorized, and it doesn't. So this works. Any questions?
List available which services have AD authentication?
Great question. Jan is asking which services in Azure actually support this right now. So as far as I was able to look up, there are 4. All the management APIs, because you're calling them as a user already, so they're using token-based security. The Key Vault, which is an interesting one, because you can use it as a stepping stone to other services. Azure SQL DB, and data lake store. And why it's those services, I have no idea. There is, as far as I'm aware, no promise whatsoever to incorporate this into more services. But I do know that Azure Storage and then the files portion within that, there is high demand for being able to access that using an identity, because they wanted to start using that as a replacement for on-premise Samba shares. But nothing out there publicly, as far as I know. So that's a con. Again, service identity isn't general available yet. It's only available on web apps and on virtual machines, by the way, but you don't want to use virtual machines. And the pro, no more secrets, which is a great thing. So that's what I wanted to share with you. 4 ways of getting your secrets into your application in DevOps scenarios. So, quick recap, what do we use when? First of all, we can let team operations deploy. Let's not do that. Secondly, when we cannot control or access the infrastructure, we're going to use our release orchestrator to insert secrets. If we can change, or at least touch upon the infrastructure, then we're going to use ARM templates, or if we cannot use the templates, at least Key Vault. Managed service identity comes into play when allowed. That way we can access directly the Key Vault, or if possible, any application that supports receiving a bearer token and granting you access using that. So, one thing you might be wondering now, Van Henry, you have still been using those secrets in your web config when developing locally. So you're a hypocrite. Well, there is a new thing which I've been playing with all last weekend that I wanted to share with you, and that's config builders. Has anybody heard of config builders yet? Okay, a config builder is a new construct that you can insert into your web config, and you can. What it will do is when it's registered, it will take a look at your web config variables, and if there are any that it knows how to change, it will change them. Sounds a bit fake, so let's take a concrete example, that of the Key Vault configuration provider. You configure it with a locator to a Key Vault, and so it will go to the Key Vault, retrieve all the secrets, compare them with your web config, and it will override any that match. And you can use this both in Azure and locally. So this is one of the things I think that was promised quite a while back already, but it's actually delivered now. It works on either .NET Framework 4.7.2 or higher, which doesn't exist as far as I know, or .NET, and you will need the .NET Framework 4.7.2 development tools, or you can use ASP.NET Core 2.0 or higher. Now this sounds really amazing, so I've spent a weekend playing with it. This is what I got. Big fat failure. I didn't get it to work at all using the instructions on MSDN. A lot of Googling, going through GitHub sources. So what I did, let me first share how it works. What you do is you take your solution, you're going to add a connected service. You do a lot of debugging and Googling. Then you find out that's not working. You're going to update the NuGet packages to the latest version. Then you're going to remove some of the parts of the configuration of the config builder. And you go to change them based on MSDN. And then finally you're going to see that you cannot access the Key Vault as promised, and that you have to put in a connection string yourself, that connection string does not contain any secrets, but again, it's not working, and the only way it works is when you're using a connection string with secrets. So kind of defeats the purpose of the whole exercise. I will show you this shortly. A result, still secrets in web config, and the reason it's still going to rely on your identity as a developer to be able to access that Key Vault. So we're back to scenario 3. Shame. That's what I just said, right? So I've been working on this example for the whole weekend. Again, I have the secret bank account password that I wanted to update for my Key Vault. And as I said, we can register one or more config builders. There can be more, comma separated, that are going to operate on our app settings at runtime. And there are a number of them, and I've chosen to use the Azure Key Vault config builder, no surprise. And what I've changed my code to is a full connection string in a new format to use an app ID, a tenant ID, which is here, and an app key, so let's fix this quickly, to access the key vault. So back to the problem I started off with. However, I do think this way of using config builders is the best way to move forward with secret management once A, it's working, and B, you're working with one of the supported versions of the .NET framework or .NET Core. For now, and if it's working, you want to change that connection string to this. Run as developer, developer tool Visual Studio. And based on your identity, you're going to get access to the key vault. That's a promise that's out there, but so far it hasn't been fulfilled. So that's what I wanted to share with you. I hope this does help you to move forward in your DevOps journey and also get more security going on in deployment of your code, which I think is an important thing. So do try this. Thank you for your attention. And if there are any questions, I will take them happily. Hit me.
Yes, I actually two questions. Like you mostly showed examples for Azure. But
Yes.
if you work, for instance, with still like a local environments or corporate AD or whatever, so there are at least two other additional ways to do it. Like sometimes you mentioned use certificates, which is a big pain to use it. But for some components, WCF services and so on, you can just make a reference to a certificate. So in the production, you have one certificate, locally you have another one. So you have two web configs and this kind of works. This is number one. Number two is one more approach is that you can take those secrets, like if you don't have a dedicated DevOps, you don't have dedicated admins, or just developers. Maybe like you just take those secrets, you encrypt them, and you place the encrypted values into web config. And then you have two ways to do it. The one way is actually to use a data protection API, which is like encrypted as user key or machine key. And another one is that you can just encrypt yourself. But you should be really careful with it because you should have like symmetric encryption with HMAC and some strands and so on.
So the remark is there are other ways to do this. If you're working with a local environment. So the first approach you're suggesting is we can use certificates.
For some tasks, yes.
Yes, and of course we can always take all our secrets, encrypt them with the public key, so we can use certificates as an encryption, decryption mechanism as well. The thing is, how do you get certificates to the machine where you need them?
Then you need really an admin. You should have a developer and an admin install that certificates.
So you're basically back to having some prerequisite on your environment, or having the operations team do it. And I do acknowledge that in a lot of scenarios this is still necessary. But if you're going for greenfield, cloud first, DevOps, every check into production, then in my opinion you want to try and avoid that kind of scenarios. So this is really with looking forward. But you're right, there are ways you can for example, use certificates. If you're stuck on Azure Cloud Services, you can also provision certificates through a neat interface to your application, and they can retrieve them from the certificate store.
The second approach is also to use encrypted values inside your web config. You can just run as debug, unencrypt on the fly, or when release, you still have it like file by file. You release on the same one, but then was need some kind of a pointer. Like either a file which could be used to decrypt or something else. And then with those keys, probably senior developer can just put them once, and then junior developers can develop as local.
So the second thing you're suggesting is we can also encrypt our secrets and then decrypt them on the fly. And we can have one person just managing the keys and nobody else can. I have two issues there. The first one is what if what we call a Tim onder de trein scenario. What if that one person who has access to the keys or the two persons that have access to the key are currently not available and there's something going on?
Yeah,
So
it's a combination.
okay, and
Rule of traffic applies to
okay, and rule of 3. And secondly, what are we going to use to decrypt those secrets?
Sorry?
So we are going to encrypt secrets. Let's assume asymmetric encryption, so we can get everybody the public key, so everybody can ship secrets to production. That's great. But how are we going to manage the private key in our environment, our runtime environment?
So for let's say a production environment, the approach we once used was that somewhere on a shared folder, let's say an AD server, but only for local environment, you have a file which is protected by ACLs, and then only this application grants access to it.
Okay, so you're assuming some pre-existing infrastructure to deliver that certificate.
Yeah, but to do it like generate it once or something, and then
It's a valid approach. I agree with you there, but
there are two keys, one production environment, one local, so developers can always use it locally as well.
yeah, you're probably going to switch between different sets of secrets. Fair enough. It's a valid approach, but it will rely on some pre-existing infrastructure. It will rely on a one-time setup. So if you want to spin up new services like on a daily basis and just get them out there are things that are starting to slow you down using these approaches. They are valid, but
There's also a difference between if you're using Azure or if you're using a local environment.
yeah.
Because you probably will not use Azure Vault in a local environment. There are some alternatives to the server, some, but
Ah.
there.
Choices. There are a lot of options. I agree with you there. And I think everybody has to pick the one that fits his scenario best, depending on his or her requirements. Anyone else?
Not necessarily a question, but there's a good session done by a guy from Netflix. He explains exactly how they do the infrastructure. It's called turtles all the way down. Like once you have one turtle, then you install the other one, you have the other one, and then the other one. It's like 20 minutes and finding out. I think it's a name, but it's it's similar with an data. I think it's all AWS. Same problem solved in different ways. You talked about that's how they solve it.
Okay, cool.
And it's similar. That's how Azure does it. Let's say you partition that there is something in place and it will get the secrets when it needs it and no other location.
So the addition for all the people at home, there is a talk called Turtle All the Way Down, which talks about the same issue and how Netflix solved it using AWS. By the way, all the concepts I've talked about, like a key ring, managed service identity, they are all available on AWS as well. So this is not just Azure. The concept translates to at least AWS. Google Cloud, I don't know. Any more questions? In that case, thanks for your attention and enjoy the day.